All right, so as I was talking before, I bought this tool in 2019, February of 2019, I got it. And the thing that convinced me to buy it was when it was purchased, Shaper was purchased by the parent company of Festool and SawStop and Sustainer. So I figured they're going to be around for a while. I can rest in good, I can in good faith believe that they're going to be around if I have an issue down the road. And incidentally, they're there for support, and that I think I'm on my fourth or fifth upgrade in the 2 or 3 years I've had it, 3 years I've had it. By upgrade, what I'm referring to is this is a software-based tool, and they've gone through different versions. A couple of months ago, I just downloaded their latest version, and it adds some new features. It makes some things that were a little tricky before easier. So they're constantly developing this, and it's been pretty nice. One of the things they added 2 revisions ago, or 2 updates ago, I should say, is they added the ability to do finger joints on the tool. So you don't have to program or anything, but you can do finger joints. And I'll try to remember to show you a little bit about that. One of the things I'm going to do tonight is I'm going to try to show you stuff without making a racket and without wasting a lot of time cutting things. So there is a way on here to do, when you select the depth of cut, if you select air cut, it goes through and does everything it would do except lower the bit. And it doesn't require the router motor to be on. So I'm going to do that a lot tonight, just because it's a quicker, easier way to show you things. And I won't have to even set up pieces of wood for it. But at the end, I will do some cutting, just so you see what I'm talking about, how it works. But kicking it off, I'm going to just go through a little bit of what it does. Let's see if I can get this camera here. So this black piece right in here is the clamp for the router motor. It's a little carriage that floats, and it can go about 1 inch in any direction. And so when you are following the pattern that you're trying to cut, what you're really doing is you're really looking at that portion there. It's what it's doing is it's looking at that line that you're trying to follow, and it's adjusting for it. So if you're off a little bit, it'll correct within a certain amount. And if you get off beyond that amount, rather than letting you go ahead and screw up a piece of wood, it will automatically lift the bit out of the wood, and it'll do it really fast. I think I have only 2 or 3 times in 3 years have I actually nicked a piece of wood. A little like the SawStop, you get a nick, but it doesn't ruin it, right? I think 2 or 3 times when I had some tough grain and I was trying to cut deeper than I probably should have. I had a little bit of pressure going, and I did something like, I had forgotten that I'd cleared out an area before or something, and I went into that, and of course, all of a sudden there was no resistance, and very quickly I went, and it wasn't quick enough to save me on a time like that. But generally speaking, it really does a very good job of keeping you from making the mistakes if you go off course. And if you go off course, you don't have to start over again. You just go to where you were and pick up where you left off. So anyway, one of the things I said in the notice for this that I'd talk about too is the origin versus a gantry style, a conventional style CNC. And I have about 6 or 7 months ago, I bought a gantry style, small one. They'll do 32 by 32 inches. And you might ask, why did you buy that if you got this? Well, I'll tell you a couple of things that this is good at and that isn't. And I'm just going to switch back to this other camera while I get a little example. My daughter does embroidery, and she wanted me to make her these thread bobbins, and they're 1/8 inch Baltic birch, and they're not hard to make, but they're a pain in the rear. When somebody asks you for 40 of them, you make 40 of them, and then they want 40 more. So when you're standing there cutting those things out, it doesn't take each one long to do, but when you can set up a file to do it on a gantry style, conventional CNC, you can start it going and walk away and do something else. It's a lot easier. So that's one advantage. This is for the person who says, I don't want to do anything. A CNC machine isn't really woodworking. It's doing it all for you. Well, this doesn't do it all for you. It's like any other tool. You learn how to tell it what to do, but you're holding the handles when it takes off. So you're actually controlling it, as you'll see. So that's one thing. The other thing that I brought up briefly is that this is a 2-axis machine. It really is 3-axis in a way, because it does control depth. It controls how deep the bit is going, but it doesn't do it dynamically. So in other words, it doesn't allow you to do a 3D, a carve something 3D that has elevation change in it. You have to tell it you're going to 1/2 inch deep, you're going to 3/8 of an inch deep, whatever, and you're not going to do that on the fly. So consider this a 2-axis tool where a gantry style is 3. So that right there limits it. So what's this good for? What makes it better? One of the things is the fact that you don't have the size limitations. I mentioned 32 by 32 on my CNC machine. This theoretically can do much, much larger. I'm going to see if I can show you something by sharing a screen. Hope I can find the right one. We'll try this one. Oh, I can't do it. Sorry. Scrap that. I don't have that sharing screen enabled on my laptop. But I'll tell you about it. It's probably the most impressive example I've seen of something this can do that you could not do at all on a conventional CNC. This was a guy who was a floor designer. And apparently, who knew, but they have floor competitions for people who do really fancy floors. And this guy had the idea for this floor many years ago, and apparently it would have been possible, but almost prohibitively difficult to do any other way. When he got this Shaper Origin, he was able to do it. And what he did was he had a client that had a music room, and he had, like a piano and a harp and all this stuff in it. And he had 2 doors on 2 walls that were 90 degrees from each other. So one came in and went out over there. So, this kind of thing. And what he did was he inlaid into the floor, using this, he inlaid a musical staff, all 5 lines going in one door and kind of waving along out the other door. Then he put the clef, the time signature, all of that in there. And the guy whose, the guy whose music room it was, had some favorite classical piece. I can't remember what it was. The guy put in the first 9 measures of that piece in the guy's floor. And it's absolutely phenomenal. You can find pictures of it if you search for Shaper Origin music room floor. You can probably find it that way. It's absolutely the most impressive thing I think I've seen. You certainly have a hard time doing it on I don't know how you do it on a CNC machine. The only thing you could do conceivably would be to make a whole bunch of templates and use a guided or a bushing on a router or something. I can't think of any other way to do it, but that would be really, really tough to do. And he did that, and he inlaid it. And I believe, if I remember right, he inlaid it with ebony. So pretty impressive. anyway, so there are some things you can do with this that you would find impossible to do with a gantry style. And there's something like a three-dimensional thing that you can do with a gantry style that you can't do with this. So it's what are you looking for, I guess. This is great for doing templates. I've made a lot of templates with it. But the other thing I wanted to talk about too was that there are things you can do on tool. And by on tool, I mean that are built into this, that are, there are things that they have routines built to already do. So you don't have to go to a computer and design the project and import it to this. You can just do it on here. And I'm going to show you a couple of those types of things. I think I'll start by showing you a little bit about the interface, and we'll go from there. We'll get to the on tool things. That's a major point I want to make, because I know it is a concern with a lot of people in using something like this. So this is the display of the machine. And right now I'm on design, but I'll just go up here for a minute and go to the settings. And so settings, you can see, you can set up your Wi-Fi, your profile. The info is the version of operating system that's in it right now. And then extensions. The extensions are, they added basic text capabilities into it and the box joint. And so those were things they came out with later, and I was able to download for no cost. So that's, you might have noticed, you can decide whether you want to use inches or millimeters too. So you're not locked in, whatever you're comfortable with. But then you go to scan, and scanning, how this thing works is, and let's see if, I don't know if that's, no, I think we might just have a little glare, but it isn't going to be a big deal. At any rate, these, I call them dominoes. It's the shaper tape. With the workstation, they actually have a protected piece here. It's not tape, it's printed on here. And, you never have to change it unless you happen to do something crazy to it. I probably ought to clean mine off, but anyway, when you scan, what's happening is there's a camera under here. Oh, I know what's happening is you're seeing the lights. I suspect, maybe not. Anyway, there are two lights here, and there's a camera in there, and they will read these, what I call dominoes, to learn their position. So the first thing you need to do is you need to tell it, to scan those things. And if you look, the little image of the origin, it shows an orange button on the left handle and a green button on the right. Those are the controls you're using to operate the thing, really. So when I tell it I want to do a new scan, I'm going to click it on here. And it comes down here and it says start scan. So I'm going to do the scan by pushing the green button, and then it's going to, you notice there are some buttons or some dominoes that are blue. Those are one that the machine has already recognized. But if on the edges you see the black ones, if I move over, they turn blue. So it's recognized those, and I'll catch those. I'm going to go back a little bit so that I can check the piece of work I have sitting there too. That'll become part of the picture. And then I'm going to hit done. And it's updating the workspace, and then we'll know where it's at. The other thing I'll show you is you can zoom in and out. So this is just a piece here that I have slapped on top of the workstation. See here. This part you see right here, that's just a piece of MDF that's mounted on the workstation. And the workstation has a shelf there that you can lift up and down. The main thing you got to know is that that top of your work has to be coplanar with this surface here. The let's see, I'm going to go ahead and turn on picture in picture so you can see what I'm doing here, I hope. Are we good? Yeah. So this surface here and the surface of the wood you're cutting into has to be on the same plane. And I'll show you a little bit later how to set that up. It's actually pretty easy. But so what you're seeing there is the part that I'm over right now is the piece of wood that I would be cutting. This part over here is the wasteboard underneath it. Okay. So I've scanned. The next thing I'm going to do, I have put a bit in this already. It's a V bit, but I have it in upside down. So it's basically a 1/4 inch dowel, steel dowel. And I put it in upside down because I'm going to use that to set up a grid. So the grid is like graph paper. It's going to allow you to step from point to point with precision. So I'm going to show you, hopefully you can see this. I'm going to take the little chip cover there out. And I don't know if you can see the bit in there now, right down here? Probably not. Well, oh.
Didn't look like it, yeah.
Yeah, your image is really small, Greg.
Is it right here? Can you see
Yeah,
that?
that's better.
Okay.
Yeah,
Yeah, you'll see when I go to do the grid, you'll see that bit go down, and I'm going to get it to go past the workpiece. It's very thin. It doesn't have to be a big deal, but I want it to go down because I'm going to touch that bit to the edges of it to tell it where the work is. But I don't want to go down as far as the wasteboard. So I'm just going to do that now. I'll show you on here first. So I'm going to go to grid. I'm going to tell it I want a new grid. And I'm telling it that I've got a 1/4 inch bit in it, right? That's what that is, 1/4 inch bit. And I'm telling it that I want a 1/2 inch grid. So a 1/2 inch between the lines on the grid. So now I'm going to go ahead and I'm going to set the depth. And all I'm going to do is I'm going to hit see the lower button and the raise button. I'm going to hit the 2 buttons until I get it down where I want it. And I'm just going to duck down so I can see here. So there I am. I got the right height. I'll go ahead and say set depth. Now you see it has confirmed bit size is correct. Yes, it is. So that's just a warning. You don't have to do anything about it. Now I'm just going to push this up against the surface of the wood that I want to cut. And then I'll set probe 1. So I've just set probe 1. Now it's asking me to set probe 2. So I'm going to go over to the other side here and I'm going to click it. And now it wants probe 3. Well, probe 3 is over the edge here. So it just did that. Now it raised the bit out of the way and you have a grid. And I'll go ahead and zoom in a little bit. And so you can see now I can place something where I want it. So I'm just going to show you an example.
Greg, real quick, can you give us the angle into the screen of the shaper so we can see that?
This angle?
No, the screen of the shaper.
Oh, sorry about that.
Yeah.
Yeah.
There you go.
Yeah. So there you can see the grid, and its origin, its 0, 0 point is this corner here that I probed. I set 2 points on this axis and 1 over there. And so now it's forming a grid based on that. So what I can do now, if you look up at the top, you can see it has an X and a Y. And if you look, as I move it, it doesn't move until it jumps to the next grid location. So if I move in the X direction, it's only going to go by 1/2 inch increments. So let's say that isn't close enough. I'm going to go back to grid and I'm going to say I want to modify it. And instead of 1/2 inch, I want to put in a 1/4 inch. Well, let's be really weird here and say I want 3/16 of an inch. You can enter that. Whoops, I didn't want 333. Especially, well, 3/16. Done. And now I've got, I'll zoom in a little bit, but I've got 3/16 inch increments. So you can set up a grid as coarse or as fine as you want it, is all I'm saying here. So I'll go back to modify, and I'll go back and change it to 1/4 inch, and we'll leave it there. So what does that buy you? So now I'm going to go and rather than deal with programs, projects that have been imported, I'll go ahead and turn on this picture in picture again. So rather than go on and show you things that that you have to program, I'm going to show you some things that you can create on tool. It's not a lot of things, but it's more than you would think, and there are a lot of uses for it. So you can do circles and rectangles are the two basic things, but let's just say, for the sake of an argument, let's say that I want to do a louvered shutter. Okay, so I want to put in a rectangle, and let's say it's 3/8 inch wide. Whoops, 3/7, 3/8, and 1.25 high. Okay, now one of the things you'll notice is a little box down in the corner right here. That's the anchor point. So that's where it's going to jump to. It's referencing on that rectangle I created. It's referencing it to the bottom left side. Before I go further, I'm going to make one change. I'm going to set a radius on here of 0.125. So if you look at it now, it has a radius edges. So like a shutter, slat would look like. So now I'm going to say, just for the heck of it, that I want the anchor point. It has 9 anchor points you can use on most things, but it also has, if you're doing programming of it, you can create your own anchor points. So if you need to have an offset of a certain amount, it's very easy to do. But I'm just going to select the center one, and I'm going to go ahead and put it here at 4.5 X and 2 Y. I hit the button and there it is. So now I can move it around, but that's fixed. That's ready for the machine to cut, if you will. But now what I'm going to do is I'm going to show you that you can do more than that. I'm going to go and say copy that. So the shape has been copied. There's a second copy floating on top of that. I'm going to tell it rotate it by 20 degrees. And okay, I want it rotated the other way. So I'll go back to rotate and I'll change that to -20 degrees. Oops. So now it's going the other way. I'm going to go ahead and drop that in place by hitting the button. Then I'm going to go up here to the original one and I'm going to remove it. So now I have one copy of it and it's at that angle. So all I'm going to do now is I'm going to say copy, and I'm going to position to that plus 1 inch, and click it to lock it down. Now I'm going to go copy and position the X direction 2 inches. Whoops, and -2. You get the idea. Anyway, so you can set up a series of those mortises for slats on a shutter or whatever. That sort of application you could do. I did a baby crib using this idea, and of course I was doing them horizontally rather than at an angle like this, and did a whole series of them spaced evenly and so forth. So you can do that. At that point, you would go in and you would cut them. So we've got it. We've already shown you how to, oh, a couple of other things. If you decide you need to have something that you want to put a copy of this, let's say, in a different place, you can turn off the grid. And now, you know, if I want to add something completely different, I'll go ahead and create a circle with a diameter of 0.5. I can put it wherever I want, as opposed to when the grid's on, having to move it by those 1/4 inch increments. So it's very easy to set it. And I can still get precision, because if I turn the grid off, presumably I have a specific spot I want to move it to. Well, I can again use the X and Y up at the top to position it to exactly 3. Whoops. And, you know, whatever on the X. But so that's how you would be able to put things on precisely. And the thing about this is it didn't require anything, any use of the computer. It's all done on the tool. At that point, you would go normally to cut. And you notice when I go over one of these objects I've placed, it turns the line green. That's the green, the green line is what you're cutting to. So I'm just going to tell it, I haven't changed bits, but I'm going to tell it I have an 1/8 inch bit in there. And it asked me to Z-touch it, to 0 the bit. I'm not going to bother with it because we're not lowering it anyway. But I did select air cut, which is minus 0.05. So it's keeping it above the wood. It's not going to cut. And it doesn't require you to turn the router on, but I can show you still how it works. So I can tell it that it's an inside cut. Now see how it's the gray with the dotted line moving? That's telling you where to cut and which direction to cut. And so if I were to start cutting now, it tries to, it lowers the bit, and then I'm moving it. And I'm theoretically, I would be routing that path out. I'll point out one other thing. I hit the retract button. If I hit the green button twice quickly, it does what's called auto lock, and it will start moving to the extent of the green circle on its own. So all I'm going to do is move it forward, and then I'm going to take my hands off of it. It's doing that on its own. It's doing this on its own. So that's one of the things they added in one of the revisions. It's very handy. Now you can say it didn't do the entire thing. Well, first of all, you could, well, I'll show you. One of the things you can do is you can set an offset. So I'm going to tell it that I want an offset of 1/8 of an inch. Let's not make it 1/8. Let's make it 0.1 inch. And now it's going to give you a path to cut. That's going to take that middle part out. I could have also done this by putting in a 3/16 inch bit. Then I could have cut it all in very simply, but. So that's another way of doing it. And the blue indicates that you've already cut that. Normally what they tell you on the shaper, and probably a good rule of thumb anyway, is to go no deeper than the diameter of the bit in a single pass. So if I have a 1/4 inch bit, I would do 1/4 inch steps in depth. So if I'm cutting through 3/4 of an inch of some kind of wood, I'm going to take 3 passes on it. One of the things that the offset does for you, if you look at it, I'm going to go to this next one that we have here, and I'm going to cancel the offset. We'll go to 0 offset. So you can put in an offset because you're doing 3 passes to cut that out. If you want that to be really clean, a really clean cut, and you're doing 3, you might have a 1/1000th of an inch difference between the second and the third, or the first and the second, or whatever. So if you really are looking for the best quality of cut, you might do 5/1000ths of an inch offset. So it's actually cutting, it's hard, you can't really tell it on here, but it's cutting 5/1000. I'll make it a little bigger so you can see it. Oops, wrong thing. Offset. I'll do a 0.05 offset. See, you're now not cutting to the green. Now, ideally, you would use something like 5/1000ths or, something smaller than that, but we'll go back to the 5/1000ths. So now I can do 3 passes with a 5/1000th of an inch offset. So it's cutting inside the green by 5/1000ths of an inch. Then I follow it up with, maybe on the last pass, I might, to save myself one, I could either do all 3 of them and get my 3/4 of an inch depth, or I could do 2 of them. And then on the 3rd pass, I'm going to go and I'm going to tell it 0 offset. So now it's going to go that 5/1000ths closer to where it's supposed to be and clean up any discrepancy at all. So it ends up giving you a really, really nice cut. The other thing I'll show you while we're looking at these little shutter mortises, I guess, is I have it set on its inside cut. So if I want to go, what if I wanted to cut that shape out of a piece? I wanted to save that piece for some reason. I could go outside cut. And now it's telling me how to cut it on the outside of the piece. So if I was cutting that piece out for some reason, a plug to fit into a knot that is in one of my boards, I want to conceal a little bit, I could cut that out, then cut a mortise over that knot and put that in as an inlay. So it would hopefully be a very little notice, draw very little attention. So that's 2 of the ways you can do it, inside and outside cuts. You can also do an online cut. And again, if I have an 1/8 inch bit, what I'm doing in that is the dotted line is actually where I want the thing. That's how I designed it. So I'm cutting a 1/16 on the inside and a 1/16 on the outside. I'm cutting dead on the line. So that's another way to do it. When would you use that? Well, let's say you're doing this. Let me go back to design and create and do a basic test, NCWA. And I put it right there. So now I can go in and let's say I'm using this same V bit, but I turn it around and actually have the point down. So it's actually doing a very light engraving. So I go to cut, and now I'm going to tell it, in this case, I would use an engraving bit, and I'll tell it engrave, and you just notice it's changed the depth automatically to 0.02. So 2/100ths of an inch deep. You can change that. That's its default for an engraving, though, an engraving bit. Now, I don't want to use any depth because don't want to actually cut anything right now. So I'll go back to air cut. But this is a great example. If you watch, what it's going to do is it's going to go down and follow that path to do the end. But what I'm going to have you look at, and see if I can give you a better close-up of this. Watch what the motor is doing and think about the fact that it's cutting an end and I'm not going to move the origin at all. But if you look at it, if you remember what you were just looking at, the N is all within the range of the tool without me having to move it. So I'm just going to go ahead and tell it to go. It's putting the bit in, it's cutting the end, and you see how it's moving back and forth and actually over. So that's how it, I'll retract now. So I can go back to this and you can see it's blue. It's cut that with a 1/8 inch bit. But if I were to put it in as an engraving bit, okay, and I'm dismissing the zeroing, you can see now what it will do here. If I keep it as air cut, but what I've done is I've kept it as an air cut so it doesn't go into the wood, but I also told it that it's an engraving bit, so it's only 0.02 inches diameter where it's cutting. So I've just cut that C out. I've just engraved that C, I should say. I should have an example I can show you here. No, I don't think I do. Oh, well. But yeah, you can do sign work that way very nicely. Let me go ahead and go back, and I'm first going to clear the blue things that tell you where you've cut already. Then I'm going to go and remove these things. Remove this object. And remove this object. And that one. So we're back with a clean slate. So those are things that you can do on the tool without ever having to do any programming with your computer. So from there, and I do want to point out, you can see it over here, you do have the ability, that plus and minus is the zoom amount. So you can always go further out and get a better overall picture, or zoom in to some extent to get a more of a close-up. That's something they changed in this last version. It used to go to the point it thought you should be at, and sometimes it wasn't where you wanted to be. So that was a big improvement. Let's see, I guess at this point, let's go and talk about projects that you might have created. And how you would load those. So they can be a lot more complex, a lot less simple. And I'll go right to my first big project if I can find it. So what I'm going to do is I'm going to import it. It's on the network. And we'll go back here and I'll see if I can spot it without going by. I've done a few programs here. Few projects. Okay, PC joint. So this is that pin and cove that I am kind of fond of. And just to show you, that is a design that I came up with. I didn't come up with the pattern, I just implemented it, I guess. And we'll zoom in a little bit. So I'm just going to go ahead and select a spot and drop it down. And then I'll zoom in and show you what's happening here. With the origin, I showed you how to do inside, outside cuts, online cuts. There's also another kind that's called a pocket cut, which is basically hogging out the inside of a space. Okay. And I made notes here that are not part of they're there for informational purposes. Drawer side, pinholes, interior cut, gray coves, pocket cut. So there's a second way of telling it ahead of time what kind of cut you want to make. And that is, if you're doing it and you're designing it, you can do that. So an exterior cut is black stroke, in other words, black outline with black fill. I'm sorry, with white fill. That's an interior cut. So that's why those circles, those pins, are black lines with white centers. That's an interior cut. So you're creating a hole, basically, is what it's saying. Then the other part, the part that's green right now and gray in the middle, if you look at that, that's black with a gray interior. Gray fill is a pocket cut. So if I go here to cut, it's going to automatically, you look over here, it can automatically see it chose pocket cut because it read the fact that that's gray from the file. If I go here, it's going to go and it's going to do an inside cut. it already knows that because that's a black stroke with a white fill. So it knows inside cut. So you can do that when you're programming. I'll be perfectly honest. I don't most of the time. I just draw the project, the outline of what I'm doing, and then I change whether it's inside or outside on the tool. It's easy enough to do. And to be perfectly honest, it's messed me up a couple of times because it defaulted to, let's say, an exterior cut, and I said, okay, I'm ready to make this cut. And I didn't realize it was doing it as an exterior, and it didn't, and I wanted it to do an interior. So you can get messed up by that. It's kind of nice if you're programming it anyway. If you're making the drawing anyway, make the fill and the stroke the proper color to do what you want to do. You'll save yourself some headaches, but don't always do what I do. I guess do what I preach, don't do what I do. Anyway, so if I were to do this project, I would be using a 1/8 inch bit, and I'm not going to zero it. And I would go along, and again, I'm leaving it at air cut, but I would, depending on how thick this is, I would do it to, anywhere from 1/8 to, 1/2 inch or whatever. And I'm just going to go down the line and dismiss, and I'll cut it. Okay, it's doing that one. And you might notice that if you look at the white dot in the middle, it's going in kind of a circle. That's doing a helix cut. And it actually it's the hole is bigger than the bit. And so it kind of goes around as it descends. You can see the white dot in the middle kind of going a little crazy. And then as soon as it reaches the bottom, it pops up again. I'll also point out that I don't have to have this dead over it. If I'm right here, it's still gonna go ahead and do the same thing. The green circle that on the tool is just, or the white circle in this case, is just the area that the origin can adjust within. So now I'm just going to assume that's all done. So I would go in and I would pocket these parts out. And so notice they don't go all the way to the green line. I'll show you why. But first, let's do a couple of these and pocket them out. So again, I'm just going to descend, and I'm just going to, in this case, move it manually. Go to the next one. And you think about trying to do this with a regular router and how hard it would be. And I can just tell you that I've done this quite a bit, and it's not hard at all on this. So now I'm going to change this. It defaults to a pocket cut, but the pocket cut doesn't bring it all the way to the edge because you're hogging material out. So you're going back and forth trying to get rid of it, and you're not paying a lot of attention. So it gives you a safety zone. So now when I go and I tell it to do an inside cut, did I tell it? No, there we go. So now I can go and I can start here. And now you'll see how it's doing all the way up to the line. And so you go along and you do this. And again, you are controlling the tool. Again, that's one of those things that people object to with CNCs, is that you're not really doing the work. This is the joint that is making. Okay, and this one's together. I have one that is not here. So this is what we were cutting, or acting like we were cutting right here. That's what it would have ended up. And this is the opposite side of it. And again, they just pop together. This is a little loose because I made this almost 3 years ago, and it wasn't, I think I overdid the snug, or made it too loose rather than just snug enough. I'll get into that in a minute. Other things you can do. Here's something I did as a experiment one time. Is that and this. That's a different sort of mortise and tenon, through tenon, and it's very snug. I'm not even going to do it because I probably won't get it out, but it does fit. You can see on here some unusual butterflies, or maybe not all of them are. This one's a little unusual. I've done some that are way more unusual. Let me show you a butterfly real quick. And how you would be able to do that. Let me get rid of this. Erase and remove. Okay, so we got a clean slate again. And we're looking at the actual wood below the bit right now. I'm going to import another project that I have, butterfly inlays. And let's pick, I don't know, a weird one here. How about an I-beam? And I'm going to say that one of these lines over here has
Yeah, we can't see your screen.
Oh, my bad. Yeah, just yell at me if I do that. I forget which one I'm on. So I'm over here. I'm going to try to pretend that this line going along here is a crack. And so I want to first rotate this. Let's try 15 degrees or 14. Probably want it a little more. Let's go 18 degrees. And now I want to do another thing. I want to scale it. It's a little too big. That's just a small crack. So I'm going to make it, instead of 2 inches high, the chain indicates that the width and the height are linked, and it's going to keep the same ratio. And I'm just going to tell it I want it 1 inch. That looks better. So I'm just going to place that there. And now I can go ahead and I can cut the, let's change it to an inside cut. And I can go ahead and cut that out. And again, I've got it with 0 offset. So it's cutting right to the line that this is set to. And then I can go and I can tell it, let's hog out the rest of it by changing it to a pocket cut. And I can do this sort of thing. And you got your pocket for your butterfly. Then you go to another piece of wood, put another piece of wood in, and you again go so that the grain is going this direction here. And you lay the same butterfly down at the same ratio, 1 inch high. And you go to an exterior cut, an outside cut, and you cut it out. I'm going to get rid of this. And you cut it out. And once you got that cut through, you now have this piece, that's your actual butterfly that you're putting into the other piece, the pocket that you cut. Now, is it that easy? I'm leaving something out. If you make both of them the exact same size, your chances of them fitting are pretty slim. They're going to be more than likely that that piece you cut out is going to be hard to fit into that pocket you cut. So what you want to do again is use the offset. You want to take, what I generally do is I cut the butterfly out first. And then I go to the piece that I'm trying to inlay it in, and I cut it to the default line to start with. I test fit it, and typically it's not going to fit. I need to have a little bit more room in there. So I go in and I tell it I want an offset. But this is where it gets kind of funny. Let me get rid of this line, the blue background, and I'm going to change it back to an inside cut. So I'm back to doing, let's say I had cut this already to the green line. So we've established that a offset that's positive, let's say 0.1.
Should we see the screen again?
Thank you. Just say, hey, I'm a moron, you know. Let me try 0.5. So I just told it to do an 0.5 offset. And you see, as you do a positive offset, 0.05, it is going further inside. So by making it negative, I'll go outside the green line. So what I want to do is I want to go by, let's say, a couple of thousandths. So I'll go minus 0.002. So 2 thousandths, it's actually going to cut 2 thousandths over the edge. So enlarge it, but I'm not enlarging it by 2,000 because it's an 2 thousandths because it's an enclosed space. So it's doing it on both sides. So you're really getting 4 thousandths of an inch. It's cutting 2 thousandths further out over here, but it's also cutting 2 thousandths further out over there. So all the way around, it's 2 thousandths bigger. So you're getting a 4 thousandths overall, you know, enlarged pocket. So you do that real quick, and it doesn't take long because you're not cutting any real stock. You're just trimming the edge. You take your piece, you set it in and say, does that fit? Well, yes, it does. Okay, put a little glue in and hammer it down. If no, it's still a little tight. You go back and bump that up, and instead of minus 2 thousandths, you go minus 3 or 4 thousandths or 5 thousandths or whatever. It's pretty simple to get a really, really close fit. If you look at this piece again, this time I'm going to change the camera, hopefully the right way. If you look at the, hoping I can get this to show right. It's the reverse position that I'm trying to. Okay, there we go. You can see there is not much of a seam shown between the inlaid part and the surface. And those are both about, I don't know, 1/8 of an inch deep, you know, inlaid that deep. I left them proud just because I was messing around, but very, very, very close. There was one corner I spotted earlier. I think it was right here. You can see just slightly, you can see the line, a little bit of a line, but it's virtually nothing. I'll show you another inlay. And this is a kind of an interesting one. This was a file that I bought for $1.99 on Etsy. And I need to unzoom this again. That'll make it easier. So that was a file I found on Etsy. And while I'm at it, speaking of files, the origin uses SVG files. So it's a vector drawing. And basically what that's saying, as opposed to a bitmap, is it's not these dots are this color, these dots are that color. It's describing the outline, the lines that you're doing mathematically. So it's go from this point to this point in a straight line. make this curve, whatever makes up the curve and so forth. You don't have to worry about that. You just draw it in the program and it does that. But you want to export it as a SVG file to load into the origin. Then you can load it the way I've been doing today, which is on my network. I sit at my desk up in the house and I come up with the project. I export it as SVG, and then I have, because you own one of these, you have a password to you can sign up for what they call the Shaper Hub. The Shaper Hub is a place where you can put your own files and you can share them if you want to. So there's a large number of really good projects on it that are available for nothing, that other people have done the legwork on. So there's a ton of stuff you can get for free. What I do typically is I send all of my files to my own space on the hub, and then I download them on the tool the way I've been doing here. But you also have right here a USB port. So you can take a thumb drive, you can load them on a thumb drive, plug them in, and they'll show up on here. So that's another way of doing it. But when I got that salmon, one of the things that was a problem is that there were parts on it where you see points, like on the tail and the tip of the fin, and especially the mouth. They're too tight to get a bit in there and do very easily, particularly when you're doing the inside, when you're making the pocket. So what you have to do is, well, I'll show you what you have to do, but what I did initially is I went in and I said, how small can I reasonably get by with? I can't use a 64th of an inch bit. It's going to snap on me like that. I know I can use an 1/8 because I do that all the time. I can probably use a 16th. Might be able to get away with a 32nd. I'll show you what you have to do that. But the first step is these were bigger than that. So I had to go in and I kept the file, but I had to edit the sharp points. Even this, where it goes in like that, this part right here, from the inside, that's a pretty sharp point, exterior point. But you got to go in and you've got to massage those in the drawing program just to make them a little bit bigger so that you can get a bit in there. So that's what I did on there. I cut out one of these. And then I said, okay, now I got to pocket it. And so I cut the pocket, and well, let me show you we'll get away from this now. Remove. Okay. And yes, I remembered. Oops, import. And we'll go up here. Oops, back. Cancel. Import, back. Salmon. Download the file. I'm going to put it on here. Now notice another thing here is this is really cool, and this is not something you can do easily on a regular CNC machine. You see the scale. If I hit scale, I can make that thing, keeping the proportions, I could make it, let's see, it's 2.836. Let's make it 1. And now I got a very small salmon, a salmon minnow. I'll go back to 2.83. What did I say it was? 1? Whoops, I really messed that up. 2.836, I think it was. Okay, so I'll put that salmon down as press the green button, place it. Now, you notice those numbers up there? Those are where I adjusted it. And I needed to remember where they were, so I put a little reminder in there, but they're not getting cut or anything. So in doing this, first thing I would do is I'm going to go to cut. And I want to make it an inside, whoops, inside, not online, inside cut. And notice right by the 3, that white area, you're not able to get into there with an 1/8 inch bit. So we're going to start out, and what I would do here is I would start by telling it I have a 1/4 inch bit. And I would go ahead and cut that all out. And I'll go ahead and do part of it. I'm not going to do the whole thing. So I would go along here with my 1/4 inch bit. And actually I would allow myself, well, I do have, anybody can anybody see what I'm doing wrong? What I have set wrong on the left-hand column. Don't be shy.
Offset.
Bingo. There you go. I'm already making it 2/1000ths bigger than it was designed to be. Okay. Not a big deal for this, but we'll just go with it like that. But yeah, that was a mistake. Typically what I do is I spend a second before I start cutting anything looking at it, because I do that kind of stuff all the time. And it's really annoying. So now what I would do is I would say, okay, I've cut a lot of it out. I would then go to the pocket cut and I would cut out the middle. But then I would go to the 1/8 inch cut and I would try to whittle away at those areas that aren't quite like there. And I don't even have to cut that again. I can go right up to this and knock that little bit off. I can go over here and I'll knock the mouth off. Okay, so notice we got the top of the mouth okay, but not the bottom. So an 1/8 inch bit is too big to fit in there. So how am I going to do that? I'm going to go to a 1/16 inch bit. I don't know why I do that quite frequently. 1/16.
And Greg, real quick, you're physically changing the bit to a 1/16 inch bit, correct?
Yes. I'm trying to save us a lot of trouble by not actually doing this. But yes, I would be changing that to a 1/16 inch bit. I would, instead of dismissing this Z touch, I would again 0 it so that it goes to, it maintains the depth that I'm trying to maintain. I'm just dismissing it because to save time. So now I've got a 1/16 of an inch bit here, but 1/16 of an inch bit is fairly fragile. So here's the trick, is I'm going to go to speed here. And it has a plunge rate and an auto feed rate, if you will, inches per minute. So I'm going to change the plunge rate to 2.5 inches a minute. And I'm going to change the actual line, the movement, forward movement. And I'm going to change it to even smaller, to 2 inches a minute. Now, if we go in here and we zoom in on this, you can see the gray right by the 3 there has not been cut out yet. So I'm just going to start right before that and using that 1/16 of an inch bit. Look at how it's creeping. Putting a lot less stress on it. Looks like we need to do the same thing here. So it isn't like this machine does everything for you. It just has the function or the capability of doing what you need to know to tell it to do. So I'm creeping here to get this lower jaw done. And I'm not even moving the tool, it's doing it on its own here. Okay, so that's how you would be able to do something like that. Once you get that done, the next step is to say, okay, I've got the pocket cut out now. I'm going to take that piece. I'm going to take this piece that I already cut out and I'm going to try to fit it in there. And it fits or it doesn't. If it doesn't fit, I'm going to use the offset and make it a little bit, the pocket a little bit bigger. And what I'm going to end up with is I'm going to end up with something like that. And basically, again, there was no sawdust filling in the cracks or anything like that, or sanding dust. That just popped in and there's no gap anywhere on it. So that's what you're capable, the precision you're capable of doing with this. And I'll remind you that doing this was all done with $1.99 salmon that I got from Etsy. So I just did a search for salmon SVG file and bought it for $1.99 and boom. So there's a lot of stuff you can do without having to do a lot of programming. I will tip you off that there are a number of things that programs that people use. Adobe Illustrator is what the shaper people generally use. And I don't want to spend whatever their monthly fee is now. There's a number of other ones. There's including, can't think of the name now. There's one that you can get. It's quite capable, but it's very complicated to me. And it was, you can get a free copy of it if you're not using it for commercial purposes. And I can't think of the name of it right offhand. What I ended up doing was I ended up buying a program called Affinity Design or Designer. And it's $50. You don't pay any monthly fees, and updates when they're available are free. So I've already.
Would that have been Corel maybe?
No, it wasn't Corel. It was, oh geez.
Fusion 360.
Yeah,
Fusion?
thank you. Fusion 360. That one to me is, because it's set up to be three-dimensional, just confuses me a little more. The beauty of Affinity is it's a vector drawing program, but it's two-dimensional only, and it's much easier to do. One of the things, while we're on the topic of 2 dimensions versus 3, a difference between this and let's use that salmon as an example. If I had to go into that salmon and enlarge the pocket 3 times, all it is changing this offset and running around the edge again. That's it. Test it. It's either good or I do it again. If I do 3 times on the gantry style, what I'd end up having to do is I'd have to go up to the house, sit down at the computer, make the salmon a version of it that's, 2,000ths bigger in all directions. And then I would have to turn it into G code, which basically you take the tool paths and tell it what you want to do with them. And then I'd have to come down and load it on the machine again. And then I'd find out I need to do it all over again. So it's more of a pain in the rear. I believe that one of the advantages of the CNC machine I bought is it has a controller built in, so you don't have to have a computer hooked up to it. On some of the computers, you do have to have a computer hooked up to it. I suspect that would make it a little easier to do things like that, because you could sit at the computer, do it, change it to G code and have it on the thing faster, but still not as fast as this. So again, advantages and disadvantages. Scale, doing big projects on this would be easier, or especially the idea of a floor. I mean, I guess you could try to take the pieces that are going to be next to each other in a floor, and you could attempt to cut them on a CNC machine, maybe even put them together temporarily and cut the pattern and so forth, and then take them apart, take them up and install them in the floor and then, fit it, I guess. I don't know. But this, you take the machine up, you lay some tape down around where you want to do it, and you cut the pattern out and inlay the pieces. So you can do things that are already installed. You don't have to, you can take this to the site, I guess is what I'm saying. The music floor is a perfect example.
Greg, will you switch your camera angle real quick?
Yep.
There you
go. Yeah, thanks for the reminder. What I guess I'm going to do now, one more thing I think I'll do, and this one I'll actually do cutting and show you a different, everything I've done now is acting on a flat surface that's parallel and coplanar with this. I'm going to do a different sort of cut. I'm going to take this shelf off. So this is the shelf I've been playing with, and basically there's a lever that has a completely loose, sort of semi-snug and locked in place. And you basically, I'll do this real quick just to show you. Back in here, lower it. This is simply a wasteboard, because if I'm cutting something that goes right to the edge here, I don't want to go into the metal. I want to go into some scrap piece. So that's all this function is serving. So I'm going to bring this up. I'm going to put this bar here. It has these little like flanges on it that fit into these little spots right here. There's little indentations here. So, oops. I put this in and I lock it in place. Then all I have to do is, in the loose position here, I bring it up until it's up tight against the bottom of this piece, lock it in place, and I can take this off. Now this and this are coplanar. The other function that this serves is it can go behind here and lock in place. And it now gives me something to rest the back end of the tool on when I'm doing work out near the edge here. So dual purpose here. But I'll go ahead and do what I started to do and take this off. Set it aside. And what I'm going to do is I'm going to do an on tool joint. And I'm going to actually cut this one so you get a feel for it. So this is a stepped tenon. One part is round, the other part is a radiused square. And so it basically fits together like that. And again, quite a nice joint. And it's a little proud here because I figured better to have it proud and sand it down. But if I glue that in place, one thing you don't have is you don't have the ability for it to twist on you because it's rectangular inside. So kind of a nice, fun joint. And you don't have to make it round. You could make this, you know, another square, or rounded square, or whatever you want to do. But I'm going to make it like this. And I'm going to start by bringing out, there's two posts here. And they are at a 90 degree, they're positioned at a 90 degree to the top. So what I'm going to do is I'm going to put this back on. Okay, and I'm going to take a couple of clamps. And I can put this block with a square end up. And I'm going to bring it over against those two pegs and up till they're touching the bottom side of this bar. And at that point, I'm going to clamp it in place. Again, double check it. Get it just snug, and then be absolutely certain. And I'll put the other clamp on just because I don't want the darn thing to move. And at this point in time, I am going to set this camera aside for a moment. And I'll show you how you change the bit on it. So basically there is a hex head deal here. Just loosen that. This unplugs from the side of the origin, like so. And then it lifts up. So I will now try to do it here so you can see a little bit of it. That's the upside down V bit that I was talking about. I'm just going to go ahead and take this like a normal collet. And there's the V bit. And I'm going to put in this 1/4 inch spiral bit. And that is all there is to changing a bit. One thing you do have to remember, I have been guilty of forgetting this probably, once every 10 or 15 times I use the tool. I change the bit and I forget to tighten this screw. So what happens is when it lowers the motor to 0, the bit hits the top of the wood, and instead of registering as 0, it just pushes the motor up and out of the way. It's like, okay, I forgot again. So I won't embarrass myself by forgetting this time. So now I can take this off and I can put it back here again so that I have some stabilizing help. And I'm going to go ahead, and the first thing I do, whoops, cord got in the way there. First thing I'm going to do, let me bring that forward just a bit, is I'm going to go, we are looking, let's rescan it, I guess is the first thing I need to do. Because now I don't want to look at that flat surface. That flat surface with the salmon is still there. It superimposed it over what it thinks is there because that's the last scan I did. So I'm just going to go ahead and remove that and get rid of the previous areas that I cut, reminders of where I cut. So I'll go to a scan again, new scan, start scan, and and there is my square. So now I'm going to tell it I'm done scanning, and it's going to go ahead and save the data. If I go over here, you can see my square piece here. So at this point, I'm going to go, I think it's a 1 1/8. So this is a 1 5/8 inch square piece. So I'm going to go ahead and start by doing a grid. And because this bit, I've got plenty of depth, I can go way down. I'm not going to bother with a, inverted V bit or anything like that. I'm just going to go ahead and create the grid and hit the button for new grid, lower the bit, and I'm going to bring it down quite low so I'm sure that it's resting on a good edge. Bring it, set the depth. Oh, what did I do wrong? It still thinks I have a 1/16 of an inch bit in. So I have to tell it I have a 1/4 inch bit. 0.1 there, 0.2 there, and the other side, and there is my grid. However, that doesn't help me too much. Let's change the grid to modify to 1/8 inch grid. And let's see, we are a 1 5/8. So 13/16 would be the middle. So let's just go to, let's go to a 1/16, just to be sure we hit it.
Greg, should we be seeing your screen at this point or not really?
Yeah.
You have to remount your phone, I think.
There you go. good point. Glad somebody knows what I'm doing. Okay. Okay, so I'm going to tell it that I'm doing a 1/16 inch. So I think we are, let's see. Actually, there's another way of doing this. It would make it clearer. Let's change the grid to be 13/16. Wait, what did it do? There we go. So 13/16, the middle of this 1 5/8 inch piece of stock, the middle is 13/16 from each side. So I'm right there. So I'm just going to start working it around there and use a anchor point that's a center. So I'm going to go in here and I'm going to tell it I want a rectangle, and the rectangle is going to be let's see, 1.125 inches, and the height is going to be 1.125, whoops, inches. So I've got my square. Now I'm going to tell it that I want a radius of 0.25, and I'm going to use the anchor point as the center, and bing, there we go. So there is this part of the piece we're going to make. Now we'll do the circle in the middle, and that's a 5/8 inch circle. So I'm going to go create circle, diameter 5/8, whoops, eighths.
Greg, did you set the depth of the square?
Not yet.
Did I miss that?
Nope, not yet.
Oh, okay. You got there.
What did I do here? I did this wrong. Diameter, whoops, is 5/8. There we go. And again in the middle. So that's what we're going to be cutting out. We're going to be cutting out. So we want to cut out the outside of this. And I'm going to go back and tell it that I have a 1/4 inch bit. And I'm going to, let's go ahead and Z-touch it while we're at it. So it's lowering. Yep. Let's try that one more time. It's not flush with the top. Go through that again. Before I do, I'll just go ahead and finish this and we'll get it zeroed. So I want to do, this is an outside cut. So we're cutting away around that. And we're also going to do an outside cut on this circle. Okay. Now, you might notice that even with a 1/4 inch bit, we're not getting all the way to the edges. You've got this area here that you're not cutting away. How are we going to get rid of that? We'll just use a offset to make it a bigger circle. And then we can cut around that edge. But we'll do that in a minute. So we got it set up the way we want it now.
Almost.
Almost. It's pretty cool.
2000s offset.
Ah, somebody's watching. Is that you, Charlie?
Yeah,
Perfect. Yep. You caught me.
So the other thing, Greg, I would say is why not start with the smallest diameter router bit that you need to get into the tightest corner and use the pocket function to remove the excess in the center, as opposed to having to change the bit.
Because you also have that problem. Oops, where's my paintbrush?
I know it's not easy.
You have that problem right here. See, you're not going to cut that away with it. So in order to do what you're saying, I would have to put another square around the whole outside of the piece I'm working on. Make sense?
Okay.
So, and here's what I can do. Rather than go into the trouble of doing that, all I have to do on this is tell it I want an offset of 0.1. And it just, well, maybe it's going to be 0.15, 0.2, 0.2. And there, that would do it. That would take away all of that. And all I did was make an offset. You see what I did?
So as long as the offset and the radius of the bit fit the space.
We're not even worried about fitting the space. Let me take away the offset, 0 offset. We are going right up to the green line on this. The dotted line is going to cut the edge of the 1/4 inch bit is going to cut right to that green line.
Okay,
So it's cutting that. We don't care about what it cuts out here. This is air and this is a wasteboard.
I'm sorry, Greg. I think I did ask the question right. What I was looking at was the outside radius, or
Okay, you're talking about up here?
Yes.
Okay, what I'm saying is this here is wasteboard. So we can cut into it. And if we can cut into it, if we just make this bigger, we can cut into it and go around and cut this off. Watch what happens when I go to a 0.2 offset. Now, you see, I'm cutting into the wasteboard here, but I'm cutting off that corner that we had. And my first pass with no offset cut right up to the line, to the green line.
And
So
as long as that shoulder covers,
yeah, as long as we're
you're
knocking this off, we don't care what it does to here or here.
yeah.
3 sides are air.
That was my concern was
Yeah, if
seeing the outside of that joint.
here's a better look at the post.
Yeah.
So this is air all the way around here, and this is wasteboard. So all we're doing is we're making a bigger rounded circle, a radius square. We're making it go into the wasteboard, but we're easily, do it again, 0.2. We're easily cutting off that edge.
It's close at the corner, but that's what I was,
Yeah.
that was my question.
You could make it 0.22, you know?
I'm all about fudge factors.
Yeah,
Trust
yeah.
me.
No,
There
that's,
has to-
you're
there has to
right.
always be a fudge factor.
If you were trying not to go there, you have the exact right approach. You would use a smaller bit to get closer to those edges, and you might end up, if you can't get in precisely into that edge, you might have to use a chisel for the
It would take longer.
few hairs, you know.
Yeah, cool,
But
perfect.
yeah, let me just figure out why this didn't. Oh, there we go. Yeah, it was down. I must have let it slip when I put it in place. I have found that I've had problems occasionally. When I tighten 2 clamps on it, the second clamp might be aligned so that it's pulling a little bit and it moves it down a hair. I've had that happen a couple of times. So now I should be able to, whoops, I want to put that back as a little support for the rear. Let's see if that will zero okay. There you go. Okay, so that zeroed fine. So we'll see whether the microphone does a decent job of, let's see, I got that 0.2 offset in there, 0 offset. So I'm going to cut it out initially. And I'm not going the full depth of this, just enough to show you that it works. So I'll go 1/4 of an inch deep on the circle and a 1/2 inch deep on the square. So you'll get the step and we can see if it fits in there. I think that I made the pocket on this one here. I think I made the pocket a little loose for the one that I made initially. So I don't think I'll need any fudge factor on it, but we'll find out. Okay, so 1/4 inch bit. Now I'm going to actually tell it I do want to cut to 1/4 inch. And no offset. We've Z-touched. Oh, one thing we need to do is I had set the speeds when I was showing you the 1/16 of an inch bit. I set the speeds to a slower speed. It'd take us forever on this. So I'll go to default, and on the default on the other one. And now we should be set. Again, double checking. Let's start with this one. And hopefully the mic cuts out some of this noise in a minute, but it'll be noisy for a minute. So, can you make that out? 1/4 inch deep, right around that center rectangle. Now I haven't gone to the edge yet. So we'll do that next.
There's not enough sawdust.
Yeah, it does a pretty, oh, it would be even less if I put the shield back on. Yeah, it does a pretty good job of dust collection.
It was just a good thing I put my earmuffs on though, because it
Yeah.
was awfully loud.
Yeah, I don't know how loud it was for you guys. I forgot to
I
put,
didn't hear, there was nothing.
okay. Well, I got my ear head protection there, but
Hey, Greg,
Yeah.
on the depth of cut,
yeah,
let me just ask that, because I know in a traditional CNC machine, you can set that plunge depth and it can step down, step down, step down, and it can ramp and and that's one of the differences, I believe, with the Origin Shaper, that you need to select the depth,
Yeah.
but you can pretty easily make one run, then step it down.
yeah.
It's sort of a manual sort of process, but not a big deal.
I'll show you that now because you're exactly right. That's the way it works. So I'll go ahead, rather than knock this outside part down, I'm going to do a second pass at a 1/2 inch depth. So I'll cut this, what I've already cut, but I'll cut it another 1/4 inch deeper to final depth in this case. Then I won't even bother shutting it off. I'll put in a 0.2 inch, 0.02 inch offset, and no, 0.2 inch offset, and clean up this outside here. Okay, so I'll do that, and then we should have that part finished. So anybody know what I did wrong?
You didn't change the depth back to 1/4 inch.
Exactly. So I was trying to take a 1/2 inch cut right at the beginning, and this fence piece here was a little loose, so it went and gripped and grabbed and pulled over on it. And no problem with it though. You'd see when that happened, it immediately popped up. So that's what it's supposed to do. So we've got,
Greg, it looks like it's still loose to me.
it is loose, but we don't need it now. So what I did was, what I would normally do is I would have put another piece over here. Let me show you what these things do. There are cams in here. Can you see this at all?
No.
See a piece appear there, right down here? Let me see if I can.
Yeah, we can see that.
Yeah, it shows fine, Greg.
Oh, okay. Okay, so I'll go to this one, I probably in the view here. So what that's doing actually, I'll show this one.
So those are actually pushing your scrap piece up against your work piece,
Right,
right?
right, exactly. So there are 3 of them across the face of it. And first of all, I forgot to tighten them when I changed this. But let me just put it back in an opposite way here. If I had put a piece here, which I normally do, I could have tightened it against this piece and not had a problem. The other thing I could have done, since I'm going in this direction, I could have just butted it up against this end, and that would have helped. But, you know, hey, if you can't make a mistake when you're showing a bunch of people stuff, then, you know, what's the fun in it? So, yeah, those are designed to push the waste piece of waste board against your project, so you don't get that happening. But that's okay. Now we don't need it because we just have to worry about the middle. So what are we doing here? Well, I'm just going to go down 1/4 inch this time, and I'm going to take off and cut out the circle here. So let's go ahead and do that. And then
So Greg,
Yes.
Greg, this is kind of a standard joinery scenario where if you can remove the bulk of the waste away from your final destination,
yeah,
so that when you get down to the final refined cut,
yeah,
it's a very slight slice and very clean. It's going
Right.
to be a much more accurate fit.
there's what you do when you're making it for a piece of furniture, and there's what you do when you're trying to show it fast. So
Right.
in doing this cut, I did 2/4 inch deep passes, and I did them with no offset. If I was doing this for real, I would have done 5/1000 offset on both of those passes, and then I would have done a final pass with 0 offset to trim that all up and get it right up to the edge with no load, basically. I also would have started on the outside, but I wanted to show you the shape that it was going to end up with. So I started there, but anyway.
Would you likely also make like 3 or 4 passes at a lesser depth?
No, I don't really have a problem. You know, I follow the guidelines that Shaper gives you, which is no deeper than the depth, the diameter of the bit. So with a 1/4 inch bit, a 1/4 inch deep is fine. I haven't found that to be a problem unless I'm working with really difficult wood, and then maybe I would do that. I've cheated sometimes. Usually what I do is I'll do something like if I'm doing let's say I'm doing a 1/2 inch cut and I'm using a 3/16 inch diameter bit. You can't quite do it in 2, but what I'll do is I'll make them equal cuts so that each of them is a little easier, you know, and then I'll do a final pass as a cleanup. I'll do things like that sometimes. The other thing I should mention is that most of the time when I'm doing something on the horizontal instead of the vertical, even though, where to go? Jeez. Oh, here it is. Even though this piece is really a wasteboard, it has a little bit of machining in it to sink the screw heads down out of the way of the bit just in case. So what I usually do is, first of all, I'm not usually using this thin a piece of stock, but what I'll usually do is I'll take a piece of 1/8 inch MDF and I'll cut it the same size as what I'm working on, and I'll double stick tape it to the piece I'm working on, and I'll double stick the whole thing to the bottom wasteboard. The idea is I'm not cutting into my good wasteboard, you know. It's real easy to throw away a piece of 1/8 inch, you know, MDF. But if I cut into this too much, I end up having to make another one. Not a big deal, but sort of a labor saver. So I don't know why I was going there, but I guess the point is that usually when I have a 1/2 inch piece of wood, I'm really going more like 0.6 or 0.55 or something like that, because I want to be sure I'm through it. So I go a couple of, you know, maybe 1/10 or you know, 5/100 or something, at least a little bit past the depth of the wood. So I'm going into that wasteboard just a little bit. Here's another style of wasteboard that I've used in the past, and you can see where I went past it into the wasteboard. Several places I made the same thing, but yeah. So
Greg, aren't you generally using upcut spiral cutters?
I usually do, yes, and that's what this is.
Okay, so that lends itself to, you want to go slightly through
Right.
the core material
Yeah.
into the waste wood so that it
You get a good clean edge on the
clean edge on the bottom.
Yeah. Yep. And the other thing is, if you go exactly to a 1/2 inch on a 1/2 inch piece, sometimes you get done and I don't know, you know, there's a paper thin piece left and you got to sit there with an X-Acto knife and do your final pass, you know, not too elegant. So I'll go ahead and do this and we'll see whether it fits. Let's see here, get rid of the 0.2. So
back to the screen.
Thank you. So what I'm going to do is I'm going to go ahead and keep that 0.2, as George was pointing out. Let's get rid of the edges first and then go in. So that's a good learning thing to
You're centered instead of on the inside.
no, that's not it. What I did there is I just got ahead of the bit. So the bit can adjust within this white circle. I got the white circle ahead of the bit. And so what it does is it aborts. It says you're out of line here. And so you go back and you pick up where you left off, which would be right about here. I just got to go a little slower. Happens all the time. And the interesting thing is I'm usually pretty good at it, but every time I've showed people how to use this and let them try it, that's one of the biggest things they have problems with is they're moving faster than the bit is, and they go out of the range of the white circle. And so poop, pop it up. So anyway, back to continuing. I just wanted to tell you that's what happened. See, it's my night for mistakes. I almost made that a 1/2 inch deep too, which would have defeated sort of the purpose, but. So you can see we've got what we wanted. Actually, you can see now. We've got what we wanted. Again, I didn't make this full depth because of time. But we'll pop this out. And see how we did. So this was the side I did before, which is basically deeper because of the round portion being deeper. So this won't come through, but not too bad. Not quite through. Whoops, I'm not showing you, am I? So it's not all the way through because I didn't do a full depth, but pretty decent looking joint. And again, pretty tight. There you have it. So that was an example of a joinery thing that would be pretty simple to do on this, just using the onboard tools. So you can do an awful lot with this without ever having to sit down at the computer. The other thing is you can get projects that people have already done.
Camera angle. Greg, camera. There you go.
Yep. You can get things that other people have done on the Shaper Hub. You can get them on other websites and adapt them. As long as you can generate them in a SVG file, you're fine. The other thing, again, as I said, is that one nice thing that's very, very cool about this is the fact that you can do scaling on it. So if you have a design that you bought on Etsy that's 6 inches wide and you wanted something 8 inches wide, you can tell it, make it 8 inches wide, and boom, it's done. You didn't have to do a thing on the computer. So all you had to do is take the original file, export it as an SVG, load it on the computer, and then on the screen, on the Shaper, and then on the Shaper, you can scale it. So pretty darn simple.
Greg, on those, where the workpiece sits at your lap there, it looks like it's a limit on the width, or are there longer arms that stick out toward you there? You can put a bigger board on.
As far as depth, you mean?
Right, yes.
Okay, yeah. Again, it's whatever you put on. I know it's here somewhere. Whatever you put on the shelf. The shelf has 2 screw holes on each side. And this happens to be what, 5 inches or so. This is much bigger, but it also fits on it. It covers the entire width between the arms, and it goes out to about here. And I've seen people who have done way bigger pieces. But let me just address another thing while we're talking about bigger projects. And back to the idea I started out with about people saving money on tape. Oh, wrong way. This is a tape board that I made for doing, I don't know what. I've used it a dozen times at least. And so what I can do is I can set it down. I can double stick it to my workbench. If I'm doing let's say I'm cutting 1/4 inch plywood, or 1/4 inch, whatever. I can put a 1/4 inch piece of MDF under it to raise my workpiece by 1/4 of an inch and give me a wasteboard under it. I can cut through it then. And then I can put a 1/4 inch piece of MDF under this. Now they're at the same height. 1/4 inch, assuming we have actual 1/4 inch ply, say Baltic birch or something, but it's 1/4 inch. You got both of them are 1/2 inch up. Sometimes I end up taking a sheet of 1/8 inch. I shim things. I do stuff like that. But as long as I can get that to be the same height as what I'm working on, I can make it as big as my workbench, or as deep or whatever. Another thing that people do you can, if I have a big, let's say I have a slab. I don't have to use this or that. I can use the tape directly on the surface of the slab. Now we know that it's coplanar because it's the same piece of wood that you, let's say, ran through a planer or a drum sander or something. So you have a flat piece, just put the shaper tape on it. You can cut through the shaper tape. It doesn't matter if you lose a bunch of these. If you look at, let me back up here. Okay, if you look at the upper right-hand corner, right here, you see what looks like one of the dominoes. Okay, and what it is it's when it's full like that, it's kind of like a gas gauge. When it's full, you got plenty of, it can see it's where it's at real easily. As I get close to the, when you take this piece away, it's not part of the, of what it has as a workspace right now. But I'll just get out of the way to avoid confusion. When I get closer to the edge, the front edge, I lose dominoes. And watch what happens. Now we've got a little void there at the end of the domino on the screen. And now we should drop another bit. Now we're down to the red. So I might be able to pick it up a little bit by picking up a few in the corner. But what that's telling you is, do you have enough dominoes to accurately cut? If you get to the red, you're in trouble. You know, even here, you're kind of in trouble. So sometimes when I'm doing something big and I'm way back here, I don't have enough in the foreground. It's too far in the distance. So I have to put a couple of strips of tape nearer to me. But it's really just, you know, you need to have enough tape. But again, back to the slab, you can put it around the slab like the person did on the floor of the music room. You put enough of it in the right spots and you can go ahead. So you can do bigger things that way. Another thing you can do is there are people who will take this, something like this, and let me go back to this view, and they'll cut like a hole in it, maybe a 3-inch hole. And let's say they're doing, I don't know, they want to cut a bow tie in a slab. They'll lay this on top of the slab with the hole somewhere here, put the hole over where they want the bow tie to be. And so now you can see through it, but you've got a level surface here. So you can then go and you can say, cut the, you know, move the machine over here somewhere, zero it on this surface, move it back over the hole, and tell it you want to cut a 1/4 inch deeper to compensate for the fact that there's nothing here. And you can cut into that slab. So if you cut a 1/2 inch, you're cutting a 1/4 inch into the slab. You cut 3/4, you're cutting a 1/2 inch into the slab, and so forth. So for doing some things, that works. Inlay in a slab, be it a butterfly or a piece of, some kind of inlay. You can do that sort of thing. If you want to, you can go and put tape directly on the slab and do it. So there's different ways of handling that kind of thing, but you just have to remember that your material you're cutting has to be coplanar with your tabs or your tape. That's really the key. So however you can get that. Yeah, George.
I work in 2D.
Yeah.
It's just my brain. And the Shaper Origin fits that so to a T.
Yeah.
Anytime you want to cut a shape in 2 dimensions, one edge, meeting edges that are, and I've shown a couple of photos of this bed frame I built recently, where there were curved pieces that had mating curved pieces, and those joints need to be tight.
Yep.
This is the kind of tool that can do that, 5 stars. And you can dial that in, as you said, by the thousandth at any point along the line. I just, I gotta have one. I'm sorry.
Well, I have
Do you get a commission or what, Greg?
no commissions. I wish I did.
It's a sweet deal that is, it's almost, well, it has to be stupid simple for me. And it's almost that, but you don't need to be, I know so many people that have gotten into CNC or thought about getting into CNC. And the problem was they felt like I need to be a software specialist to troubleshoot all this stuff. And my impression from everything I've ever seen on the Shaper Origin is, you know, they make it as simple as it can be, and the big plus I think for me is so much that they're the storehouse, the warehouse they have of plans someone else has already worked out.
Well, they have, let me just add this in there, is they also have now, I can't remember what they call it, but they have a number of professionals that do projects that they do charge for, but it's a fraction. I think there's probably 6 or 8 of them on the site, and there's probably, I don't know what, 5,000 projects on the site, maybe not that many. There's a lot of people, the ones that people are put in there that are free, but they have maybe 6 or 8 that are $15, $20, $40, whatever. One of them is that Fomico light that I made some time ago. That was by a guy in Germany. One of them they have now is a bench brush by someone we had speak to us, Aspen Golan.
Yep.
She made a bench brush project that is on the Origin site for, I don't know, $20 or something like that. Yep. So, and yes, you're absolutely right that, again, the biggest thing I've heard from people when I show them this is, well, yeah, I'm not a software guy. Well, you don't have to be for all of this. It certainly helps if you're going to do some of the drawing yourself, but it isn't. It's really knowing how to use a drawing program, and frankly, you know, not my forte. But I've done, you know, I made a living doing test equipment control software, so I do have a familiarity with that kind of thing, and I think that way. So a lot of this is almost second nature to me. But I don't think it's that hard. And in particular, like I said, you know, there are things that if you, it's sort of like, what's the saying, when you get a new hammer, everything looks like a nail or something like that. When I got this, I started thinking of, oh, you know, I hadn't thought about it, but I could do this or that. You know, I had just taken the block printing class.
Oh, in Anacortes.
Yeah. And
Jim,
yeah. But I was thinking of, my weak point on that is the carving of the blocks, you know. And so I started thinking about this, and I found a picture of taken from the ferry to Friday Harbor. And it was mountains and water in the foreground and Mount Baker in the background. And I have yet to finish it, but what you do in Jim's class is you take a block and you cut away portions, you make a print, you cut away more, make a print, and each print you make, or it's not each separate prints, it's separate layers on a print, is a different color. Well, it's a I can't remember what Jim called it. It's a subtractive process. You're cutting away. You can never go back and make another one. So you make, you know, 10 copies the first time you do it, because once you're cutting away that part, you never get it back. So I got to thinking that with this, you could potentially make, if you're doing 7 colors, you can make 7 blocks that were so precise that you could make hundreds, thousands of copies with them. So I started looking at it, and there's software out there that you can actually submit a photograph, which I did take this picture of Mount Baker from the ferry. I submitted it and told it I wanted 7 colors and vectorized. So it turns it into from a photograph to a vector drawing. So it simplifies it because you only got 7 colors, but it also reduces the colors to the ones that are most representative of it. And then you can take it and you can put it into Affinity Designer, and you can tell it, I want each color to be on a different layer. But you just did all the work of it. Now all you got to do is take a layer at a time and cut it out. And you should be able to take it. I've got a little small printing press right behind me, thanks to Jim's class. And you can then make as many copies, as many prints as you want with it. I've still got to get around. I made a couple of the blocks, but I haven't made all 7 of them yet. So one of these days I'll get around to doing it all. But again, it all comes back. It's a similar to process as to doing inlays. You just are cutting away certain parts of it, like you would making a pocket.
This is so much one of those building block sorts of processes where it's like, okay, we're going to build furniture. What kind of joinery are you going to use? This is in that same vein.
Yeah.
There's so many ways you can go from here.
Greg, real quick, if someone was fairly proficient in Illustrator, are you saying then they've got a leg up because they can design their things and then just bring it over to the shaper? Is that correct?
Sure. If you happen to have Illustrator and you're proficient in it, you aren't going to have any problem at all.
Okay.
You're teaching the class. You're teaching the class.
I teach it using Affinity Designer because that's what I'm familiar with.
Yeah. Huh.
But yeah, it's there's not a lot to it. And for Affinity, because it's inexpensive, doesn't require paying for upgrades or updates. A lot of people that have the shaper use it. And because of that, one of the guys developed a set of styles in Designer. And the styles actually are the outline and the fill that you need for an exterior cut, an interior cut, an online, or a pocket cut. So all you got to do is do your drawing and then pick the thing you want and tell it, I want to use this style, and boom, it's already done.
Oh.
You know,
Seriously.
yeah, it's a piece of cake. So
Hey, Greg,
yeah.
I use the Fusion 360,
Uh-huh.
and they have a little origin, I forget what they call it, basically a button. So
Right.
I designed my piece in Fusion anyways in a 3D mode, but then you can pick a face and you click that origin button and it'll export it for you, and you can just put it on the machine and cut it.
Yeah. Yeah.
Once you get used to it, once you get used to the Fusion, then it gets a little easier. It's not too hard. You could also just draw a flat shape,
Right.
and then do it.
Frankly, that's what I should have done. I started with Fusion, and the idea of extruding this part to a 3D part, I didn't realize at the time I didn't have to do that. I was trying to make it look like the finished product, not the vector drawing I needed to get there. So you probably could use it, as you said, you could use it just as a 2D drawing tool. But yeah,
the other thing that I really enjoy about it is that when you scan it, you scan your piece and you can see the grain.
yes.
So if you're gonna cut something for an inlay, or even sometimes you want your leg to follow the straight grain of the wood a little better, or whatever piece you're making, you can rotate the drawing to go right along the grain, and you have a lot more of a choice as to how you want it to match the grain. You can actually see what it's going to look like with the grain there.
Which
I
is
really enjoy that part of it too.
which is a good reason to rescan, even if even if you're cutting multiples of it. You put another piece of
Yeah.
wood in there, rescan it so you, like you said, you can see the grain. It's very
Yeah.
helpful for cutting parts out.
Well, if you're gonna do 4 legs, they're the 4 pieces you're gonna use may not be exactly the same. So if you can
Or if
get a
you're
better vision on that, that's
if you're
great.
doing a patch, you know, you've got a flaw in a piece of material and you want to hide it. You know, that particular portion of grain you're using, you want it to look as much as like where it's going to go into as possible, right? So same thing.
And sometimes also because it takes a picture of the piece, if I want a circle and just this random part of the board, I can mark it with a pencil before I scan, put a little dot there.
Yep.
You scan it, then you just take it over there and put the circle right on that dot, or
Exactly.
wherever.
One thing I didn't mention, and I probably should, is there is a pen tool on this. So if you want to do things in reverse, so you have an object that's a weird shape. I don't know, looks like a blob of some sort. You can, and you want to cut a pocket for it. It's not going to do a precise job, but you can go and by looking at the screen of the origin, you can trace that part out, and then you can go take it away and go and along that part that you traced, and you can make a dot, make a point at each point where it's significantly different. And when you get all the way around, you've got a complete representation of that object. So you can make a recess for it or something. It's not super precise, but it gives you a capability that you don't easily have otherwise. I probably could show you that, but I've sort of disassembled the setup in a little bit when I went vertical. But and I've only used that once, but it is possible to do.
That's a good one. That's a good one, Greg. That could be really fun to play with.
Well, anybody have any other questions or comments or anything?
That was good, Greg.
I have a quick question for you, because I've just stuck to the bits that or shaper sells. And I was wondering if you've experimented with different bits like a bowl bit or anything like that.
I haven't done that because this is a disadvantage of the origin, and frankly, my CNC machine uses a trim router motor too. So you're limited to a 1/4 inch shank bit, 1/4 inch or 1/8 inch or 8 millimeter. But like a bowl bit or something, generally, I mean, guess you can get them. I have a 1/2 inch shank one. So I suppose if you could find a 1/4 inch shank, you could do that, but you'd have to be careful that it's not too big a diameter and so forth. I will point out that if I didn't mention this before, because the parent company of the origin is now also the parent company of Festool, the router motor that is in the shaper origin is made by Festool. So there's a Festool 8 millimeter collet that fits the shaper origin. So that's where I got an 8 millimeter. I don't know whether Shaper sells them now, but they didn't in the past. I have used a, oh boy, can't think of the proper name for it, but it's a bit that has quarter round and comes to literally a point.
Plunge round over.
Yeah, but it's rounding over on both sides simultaneous.
Right. It's a plunge round over.
Yeah, and you can use that. You don't want to use something that has bearing guides on it, guide bearings on it, because it sort of is defeating the purpose of what the origin is trying to do. But that bit comes to a point, so you can, use something like that to round over something that you've done with let's say, a 1/4 inch straight bit. And if this is another thing I'll mention, if you do a search for shaper sessions, Jonathan, have you looked at those?
Yeah, I've watched a couple of them. Yeah.
Yeah, there's at least one of those. Those are videos that they do, I don't know, every so often, every couple of weeks, I think. I think there's 60 some number of them, and they're on different topics. Some of them are phenomenal. They had some guy that did altars and stuff for churches in Europe, these really incredible things, and he did a lot of it on the origin. All sorts of things that people do with it. But one of the things they talked about did involve, I happened to see the one, it did involve using different sorts of bits other than just the regular spiral bits and stuff. I think they were using single flute or zero flute for cutting, can't remember whether it was foam or acrylic. But anyway, for different purposes. And they were talking at one point, I think they were using larger bits than the shaft or the shank diameter. So larger than 1/4 inch bits, not by a lot, but they were using bits that had profiles on them and so forth. So you can do it. I haven't done much of that.
I thought I saw them using like a dovetail bit. Have you seen that?
They probably have. I haven't looked at that because I do think they did one on, I think they did one on sliding dovetails maybe.
Yes.
And
Yeah.
I was just gonna say.
I was wondering how they did it because
I
doesn't plunge very well.
Yeah, my guess is they started off the board and probably used a 1/4 inch bit to hog out, down the middle of it. So all they're doing is the edges, right?
Yep.
Yeah.
And so you start.
I assume that's how they did it.
And then follow it through, yeah.
And that would probably just be cut on the line and then
right, an online
and go down the middle.
Yeah.
But I don't know, I'm always like, well, it doesn't have a setting for a dovetail bit in there.
No, I haven't seen that, but yeah, that works. We were talking a moment ago, I think, George, you were talking about the profile on the bed having to mate with an opposite profile or curve. I was going to mention I had a small koa slab that had a really punky piece in the middle, and I was able to cut out that piece, and then I wanted to use a contrasting wood to fill it in, kind of like a river table type of thing. Unfortunately, I chose, I can't even remember what I chose, but it was too close to koa to really be a contrast. But the interesting part of it is I was able to get those, basically it was 4 edges to match perfectly. So it has the precision to do that kind of work.
And were the boards that you milled dead flat? Or a little bit of fluctuation there?
With the koa, you mean?
Whatever the pieces were, where the joinery came together.
Yeah, well, it was the slab, and so I cut a piece, a sort of a V-shaped piece out of one end of it. Sort of like, if this were the slab, I cut a piece out like this. And then I was able to cut, actually, I think I might have cut it the whole length of the piece. But I cut an additional part out here, and I was able to get because I did it using the software, I programmed the piece in and what cut I wanted on it. I sort of sketched it out and the lengths and the distances and was able to translate it a little wider than I needed to, but because I had that in the CAD software, I was able to then create the inside piece to go in there to replace it. And it just fit perfectly.
If you can clamp the main piece
Yeah.
solid, and then have your moving parts adjust to that.
And I think they had enough curve to them. There was enough lump, if you will, that it sort of fit in between the other two pieces, and it wasn't trying to squirt out or anything, you know?
And I think the big trick for one of those kinds of projects is when you start doing it, you don't stop.
Yeah.
It's when you have when the slab is there, the legs are ready, you start cutting it, and you do it the same day.
Yeah.
You do it as fast as you can, because once you start cutting into it, it starts moving, and joints start opening up or closing up. And
there was a video out there, a couple of year and a half, 2 years ago, of a professional who was using an Origin, and he was doing a conference table for an office. And very interesting, he cut this slab with a line that followed the grain all the way the length of it, and chamfered the top edge, and made a slot in there. I think it was for concealing cables and so forth. And then took the two pieces and put them together again, and a perfect match, of course. Just really slick when you watch them do something like that.
yeah, it's fun to watch.
Yeah. Yeah.
It's frustrating to try to do it yourself.
Well,
You know what I was
go ahead.
You know what I was thinking about doing? Remember when we watched Brian Boggs gave the talk about tapered tenons?
Yes. Yes.
This would be perfect for that, because now they have that one tapered bit,
Yeah.
and you could do it fairly easily.
Right. Right. Yeah. There's this is something I want to try on the gantry CNC, is they do inlays by using, it's a very slight tapered bit. It's a V carving bit. So it's like this. And basically they're cutting through and cutting a pocket out. Again, this isn't super deep, but they're cutting a pocket out using this bit. So there's a slight angle to it. Then they cut the piece that's going to go into it with a slight angle, and they fit seamlessly in, and then you just sand off or plane off the top portion of it that's raised above. And I've seen them do it, and they fit perfectly, and they get tighter joints than I could get with a normal router bit, because I guess because they're using one side is using the tip of the V-carve bit, and anyway, it works. It's something I want to experiment with, but I was thinking of that too when I was watching the tapered tenons.
Greg, this is the difference between those of us who got an A in geometry in
Yeah.
high school and those of us who got a C in geometry, because I mean, that's what it's come down. Execution obviously is a big part, but it's math.
It is.
And
It is, but you don't have to
there's
think
a
of it
trick.
that way. You know, to me, I've always been good at envisioning how it's like, sometimes I tell my wife, hey, if we do this way, it'll look like this. And she can't grasp it, but I can totally picture it three-dimensionally, you know?
Mhm.
And so it's just, how your mind works, I guess. I don't know. But yeah, you can do a lot of things with this. And I guess what I'm trying to show tonight is that don't be afraid of it because of the computer side of it. There's a lot you can do without the computer. It isn't that hard if you do have to use the computer. Something like that, pin and cove nap joint that I did, that was pretty tough, because you got to keep doing alternating diameter curves. And, you know, you had to watch the clearance between the pin you're trying to cut. And it was a challenging project because it was the first one I did too. But so many of the ones I do are simple, you know, it's a simple shape. And, you know, when you start talking templates, when you do a cloud lift on a green and green style piece of furniture, all you got to do is get one side right, copy it, flip it over, and you've got two sides that are absolutely perfectly matched.
Piece of cake.
You know, when I try to do that by hand, I always know that those two sides aren't quite right, you know?
But all you have to do is change the length of the piece part
Mm-hmm.
and the basic radius, and it's, and if you're doing it manually, that's a major thing.
Yeah, yeah. Well, here's another thing. What was I doing? I can't remember what I was making. It might have been I don't know. Oh, you know what it was? It was Daryl Pert's the Aurora nightstand.
Yep.
It's got a cloud lift on an arch.
On the lower rail, which transfers into the bottom of the drawer.
The drawer, yes.
Yep.
So it ends up being, I think if I remember right, there are 3 different radiuses.
Yep.
And I remember on this workbench here, way before I had the Origin, getting I think they were like, I can't remember exactly, but 52 inches or 53 and a quarter or something like that. And so I remember jerry rigging the base of a router to a board that long and pinning it to a piece in my vise on this end and cutting this arc. Tedious.
It's 12 feet away is where the
Yeah.
nail is.
Yeah.
You're pivoting off of.
No, that's it. It was ridiculous. And I look at it now and I just tell it, I just go to the CAD software. I tell it, I want a 12-foot radius. And then I take a pie-shaped segment out of it that I need. And there it is, you know, there's nothing to it. It's, it really simplifies a lot of things, but
It does.
anyway, anything else by anybody? Nope.
Well, Greg, I've got this recorded and I'll get it up on the YouTube site. So anybody wants to refer back to anything can in the next few days.
I know what they're going to hear. Can you switch that camera?
And we want version 2. And then
Yeah, there you go.
it's there, this easily transcends into another level and another level. You've done it, Greg. You did a fabulous job of.
Yeah, and you did a great job switching the camera angles and everything, Greg. That was no small feat. I know what went into that.
Well, wiring it was a pain in the rear, but switching it is pushing a button. So
Yeah. You
But
did it.
remembering.
Very good.
Remembering is the hard part.
yeah, that's the hard part. Story of my life.
Hmm.
All right. Well, that's it.